When it comes to developing solutions to fulfill existing and future facility space requirements, airport operators confront numerous obstacles. Knowing how to enhance capacity to accommodate rising passenger demand while also ensuring that all airport operations remain operational is crucial in the planning process. As a result of its capacity to increase the speed of the building process while limiting expenses and reducing the amount of exposure to airport operations, modular construction has become an increasingly popular, cost-effective choice for airport development projects. Want to know more about this construction? Keep watching this video. Welcome to Construction Technique. In this video, we are going to talk about insane airport construction techniques. But before we make it to the video, hit the subscribe button and turn on the notifications to get notified whenever we upload a new video. Modular architecture has progressed to the point that it no longer implies a lack of aesthetics or restricted functionality. Modular structures can give a smooth and natural extension of the buildings they are adjacent to or attached to, whether for a permanent or temporary application. The Federal Aviation Administration, as well as all municipal and state building code requirements and certifications, can be met with modular construction. Temporary modular buildings can be used as a stopgap measure to satisfy increased passenger demand or as administrative space while permanent facilities are being renovated. They can also be repurposed, allowing them to be moved or relocated to another location on the airport field to fulfill customs, cargo, maintenance, or other operational needs if they are designed properly. When using modular construction to produce airport expansion projects, collaborative agreements between a modular building business, a designer, and a prime contractor are ideal. The modular construction company can often serve as a design assist firm, assisting the airport's architect in the development of a project while also acting as a subcontractor, manufacturing and installing the modular building while the general contractor handles site improvements, utility connections, and closeout. When the Denver International Airport embarked on an upgrade and extension of the airport's Concourse A commuter terminal, this scenario was used. Ramtech Building Systems of Mansfield, Texas, and its in-house design team and estimators collaborated closely with Denver-based Wong Strauch Architects PC and the prime contractor on the project, Hensel Phelps. The team came up with a plan to build the 38,920 square foot Type 2B facility, which includes 6 additional gates on the east side of the concourse. The idea was to have faster talks with both the architect and the general contractor early in the planning process to determine where each company's strengths were so that the suitable responsibilities for each team member could be developed. In this scenario, the modular building company was regarded most capable of providing the structure's core and shell production and installation, including all structural requirements, window glazing installation, roofing material application, and foundation design creation. Hensel Phelps was subsequently tasked with overseeing all site development and renovations, as well as utility connections and building finish-out. The Denver Airport project was intended to be a temporary structure that would be operated for a period of 5 to 10 years before being decommissioned and relocated. The use of modular construction was excellent for this purpose, and when combined with the interim use classification, it allowed for particular foundation design allowances to be established. Bond and CMU block piers were used as the foundation to support the building in this project, as well as other similar modular construction projects. In order to establish the compressive strength of the loads when eccentrically applied, an analysis based on accepted testing data was required. To resist the wind and seismic design stresses, the modular design approach that can produce the huge open spaces required for any airport terminal requires a lateral resisting system. Shear walls were encased by thin steel plates linked to cold-formed steel framework for the Denver Airport project. The external walls of the structure and a few inner partitions from the original architectural building made up the structural elements. The shear wall's racking strength, along with the steel roof deck's strength and rigidity, allowed the architect's layout to be properly preserved. Similar subfloor shear wall elements were also used in conjunction with the concrete masonry unit foundation system to attach the building to a concrete. The foundation and building envelope were developed in this manner rather than on-site, which would have required more expensive, time-consuming, and disruptive excavation or removal of the existing tarmac. Another advantage of the project's modular design was the utilities that flowed from the existing concourse area, which were completely overhead and not below grade. The modular building method, with its added height concerns, enabled for a more seamless transition of power, data, and mechanical systems distribution without having to cut into the existing concrete. Overall, this strategy enabled for a more efficient use of the existing tarmac and site infrastructure, resulting in a faster installation and completion of the 65 modular sections that comprise the concourse expansion. The airport was able to satisfy passenger demand by using modular construction, which reduced the traditional 3 to 4 year time frame for establishing a permanent site-built project to less than a year for the temporary modular building. The concurrent nature of the modular construction process, in which the building is built off-site while site modifications and preparation are done on-site, provides a considerable benefit to airports by increasing total construction efficiencies. Fewer personnel will need security clearances and constant surveillance, and the project will reduce or eliminate the need for airport closures or flight schedule changes. The entire method cuts down on time spent on site and minimizes the size of the construction footprint required to finish the project. This applies to both the needed site construction activities and the building module installation. A laydown area equal to or larger than the building footprint must be set aside when using site-built construction methods to store and stack all the wood, steel, and other construction-related materials. The sheer size of the laydown area, especially at smaller airports, can cause logistical issues and have a negative influence on airfield operations. Because the majority of the components that make up the structure are used at the production facility rather than dropped off at the construction site, the modular construction method requires substantially less space because there is a minimal quantity of supplies that must be stored. During the installation phase, airport activities are also kept to a minimum. The modular pieces that make up the structure are normally trucked and unloaded at a secure place on or near the airport property once the building is finished being manufactured. Then, under airport security escort, an allotted number of modules that can be erected effectively within each workday are individually relocated from the staging location to an area near to the building pad. They are usually rolled into place using specialist machinery from here. Ramtech Building Systems recently completed a 7,168 square foot modular building at Northwest Florida Beach's International Airport in Panama City Beach, Florida, using this method. The modular building was built to link to the airport's current terminal to give additional passenger seating capacity for the airport's 2 regional aircraft gates. The all-steel Type 2B structure was built on formed and poured piers that extended 2 feet above the existing pavement. This type of installation would ordinarily necessitate the use of a crane to place the modules, which is not always possible at an active airport, particularly at smaller airports with limited access. A unique modular cribbing system made of pressure-treated strong lumber in 20-foot pieces was utilized to set the 9 modular components that were created in 3 different sizes. Using a telehandler, the individual modules were placed on the cribbing sections and then wheeled into place on casters between the piers. The modules were then lowered onto the foundation and weld plates were used to link them to the piers. The finish-out process was able to begin after the entire building had been set and weathered in, allowing the project to be completed in just under 90 days. Overall, using a design-build modular construction technique to fulfill the needs of a temporary or permanent airport expansion project is a great alternative. This type of application can save airports time and money as well as help them achieve their goals faster while minimizing operational disruptions. That's it for today's video. Thanks for watching. More interesting videos are coming, and if you don't want to miss any of our videos, then smash the subscribe button and hit the bell icon so that you will always be updated.